Okay students, now let us go for the length of the normal to the curve x equal to a theta plus sin theta, y equal to a 1 minus cos theta at theta equal to pi by 2. So here you can see the length of tangent is given by the formula y into root of 1 plus dy by dx whole square divided by dy by dx. The length of normal is given by y into root of 1 plus dy by dx whole square. So here you need the length of normal, that is the second formula. So let us use it. Length of normal is given by y into root of 1 plus dy by dx whole square. Clear? You have to use this formula, no problem. So here y is equal to a 1 minus cos theta, no problem. You have to find dy by dx. So if you want to find dy by dx, you have to resolve x and y through parametric form of differentiation. Through parametric forms of differentiation. So for that reason, first you calculate dx by d theta. That will be equal to a times of 1 plus cos theta. Clear? Next, you have to find dy by d theta. That is going to be equal to a sin theta. Clear students? So using these formulas, you have to simplify dy by dx. dy by dx equal to dy by d theta divided by dx by d theta. So that is a sin theta divided by a 1 plus cos theta. Cancel a and a. So here now you have to use trigonometric formulas. That means sin 2 theta, cos 2 theta, tan 2 theta, that formulas you must know. So as you all know, sin 2 theta equal to 2 sin theta cos theta. So here you need half angle formula, that is sin theta equal to 2 sin theta by 2 cos theta by 2. No problem. Here what you have, 1 plus cos theta. So for that you need half angle formula of cos 2 theta. So what is half angle formula of cos 2 theta? 2 cos square theta minus 1. Another one is 2 sin square theta minus 1. Clear? So for that reason we have 2 cos square theta minus 1. Half angle formula will be cos theta plus 1 equal to 2 cos square theta by 2. So directly I have written the half angle formula of cos theta plus 1, because if you take minus 1 on this side, it will be cos theta plus 1 2 cos square theta by 2. So that is equal to 2 sin theta by 2 cos theta by 2 divided by 2 cos square theta by 2. 2 cos square theta by 2, cancel 2 and 2, cancel cos theta by 2, cos theta by 2. So now you will get, that is tan theta by 2. So dy by dx equal to tan theta by 2. Clear? Y equal to what? A 1 minus cos theta. Here you have to use y equal to a 1 minus cos theta 1 plus tan square theta by 2. So for that you are going to have, that is y equal to, you have y equal to a 1 minus cos theta and dy by dx you have tan theta by 2. So for that reason at theta equal to pi by 2 you have to calculate your what? Length of normal. Clear? So you calculate y a 1 minus cos pi by 2. Why? At pi by 2 you need length of normal. So I will put theta equal to pi by 2. Cos pi by 2 is 0. No problem. So a into 1 will be equal to a. Clear? So in this formula y is now a. Y is equal to a dy by dx at pi by 2. See, theta is pi by 2. If you put theta term as pi by 2, it will be tan pi by 4. What is tan pi by 4? 1. So for that reason, this term will become root of 1 plus 1 square. Dy by dx will be 1 because in the place of theta, you have to put pi by 2 divided by 2, so it will be tan pi by 4. So tan pi by 4 is 1. In the place of dy by dx, you have to put 1. A into 1 plus 1 square. That means 1. 1 plus 1 will be 2. So that is a times of root 2. A times of root 2. That is option C. Option C will be the correct answer. Clear? So a times of root 2 is correct answer for this question. Okay students, so now let us go for the second problem. Let us see what they are asking in second problem. The length of subtangent at t on the curve x equal to a times of t plus sin t, y equal to a times of 1 minus cos t. That means they are asking the length of subtangent at the point of t when x is equal to a t plus sin t, y equal to a 1 minus cos t. No problem. So now let us find the subtangent formula I have written here. You please remember that is y divided by dy by dx. So first we have to resolve parametric forms. For that reason I will solve dx by dt. What is dx by dt now? A 1 plus cos t. Next, what is dy by dt? Dy by dt is a sin t. A sin t. Clear? So first calculate dy by dx. That is dy by dt divided by dx by dt equal to a sin t divided by a into 1 plus cos t. A into 1 plus cos t. Now cancel a and a. Clear? Sin t is what? 2 sin t by 2 cos t by 2. Already we have discussed in the previous problem. What is 1 plus cos t? That is 2 cos square t by 2. This is also discussed in the previous problem. So that's why I will not discuss again. Cancel 2 and 2. Cos square cos t by 2 cancel. Remaining term is tan t by 2. Remaining term is tan t by 2. Okay. So using this tan t by 2, you have to write this formula. That is y means a 1 minus cos t divided by tan t by 2. Clear? So 1 minus cos t is what? 1 minus cos t is 2 sin square t by 2. 1 minus cos t is 2 sin square t by 2. So that is 2 sin square t by 2 into cos t by 2 divided by sin t by 2. Clear? So from this you can cancel sin t by 2, sin t by 2. Tan t by 2 I have resolved here. Clear? So that's why sin t by 2, sin t by 2 cancelled. So that is a 2 times of sin t by 2 into cos t by 2 will be what? A sin t. So a sin t will be the correct answer because 2 times of a. That means a to sin t by 2 cos t by 2. Sin t by 2 into cos t by 2 is what? Sin t. That is sin t formula. So that's why a sin t will be the correct answer for the length of subtangent. Clear? Okay students, so now let us solve increasing function and decreasing function. Clear? So before solving the problems on increasing function and decreasing function, let us look at the definition of both the functions and how to solve the problems on increasing and decreasing functions. Clear? Okay. So let f of x be the function. Let f of x be the function in the open interval a comma b. Let f of x be the function in the open interval a comma b. From this interval, I will choose two elements for x1 comma x2 belongs to a comma b. I will choose two elements x1 and x2 belongs to a comma b. Then or I can say it as if f of x1 is lesser than f of x2, f of x1 is lesser than f of x2 for x1 is lesser than x2. See, for x1 is lesser than x2, f of x1 is lesser than f of x2. That means for these two elements in this interval, f of x1 is lesser than f of x2. So where x1 is also lesser than x2. Are you understanding the relation? If these two are in the form of x1 is lesser than x2, then f of x1 must be lesser than f of x2. Then we say f of x is increasing. F of x is increasing. This must be for every x1 comma x2 belongs to a comma b. That means in this interval, if you choose any elements, if x1 and x2 are x1 is lesser than x2, then f of x1 must be lesser than f of x2. Are you getting my point? If this condition satisfies, then that function is going to be an increasing function. That function is going to be an increasing function. Then what about decreasing function? See here, everything is same, but for x1 is lesser than x2, if f of x1 is greater than f of x2, just the change in inequality sign. For x1 is lesser than x2, f of x1 is greater than f of x2, then it is decreasing. Then it is decreasing function. Clear? So again I will explain, listen carefully. For the function f of x in the open interval a comma b, for the function f of x in the open interval a comma b, for every x1 and x2 in the open interval a comma b, f of x1 is lesser than f of x2 for x1 is lesser than x2. Then we say it is increasing. If f of x1 is greater than f of x2, we say it is decreasing. Now let us look at the problems and algorithm of problems, how to solve this increasing and decreasing functions. Clear? Okay students, if the function f of x is given, if the function f of x is given and they ask to find increasing and decreasing functions. Again I am telling, f of x is given and they will and what is or f of x is given, and they ask to find increasing function and decreasing function. So if they ask like this, what we have to do? You have to differentiate the given function, that is f dash of x. You have to calculate from the given function, you have to differentiate, and if this f dash of x is greater than 0, if this f dash of x is greater than 0, it is increasing. Clear? Suppose f dash of x is lesser than 0, it is decreasing. So please remember it. Clear? If f dash of x is greater than 0, it is increasing. If f dash of x is lesser than 0, it is decreasing. So we shall try to find the problems and we shall simplify some of the problems. But before going to these problems, you remember the wavy curve method. That is, by solving algebraic equation, if you get x equal to a and x equal to b, I am telling, by solving algebraic equations, take one algebraic equation, ax square plus bx plus c equal to 0, you resolve it. If you get these two as the roots of this algebraic function, a and b, in the place of a and b you can take alpha comma beta also, alpha comma beta. If you get alpha comma beta are the roots of this algebraic equation, you have to arrange them in ascending order. That means alpha lesser than beta. Suppose alpha is lesser than beta, here alpha comes first, beta comes next. Alpha comes first, beta comes next. By arranging this, again you have to go for this function. Suppose this function is positive, you should start from positive side. If this function is negative, you have to start from negative side to draw the curve, that is like this. Clear? So this is the negative function graph, and this will be the positive function graph. That is, if this term is greater than 0, you have to go with solid line. If this is lesser than 0, you should go with dotted line. Are you getting my point? So if you take this type of graph, here it is positive, it will be increasing. Here it is negative, it will be decreasing. Here it will be positive, it will be increasing. If you come for dotted line, here it is negative, decreasing. Here it is positive, increasing. Here it is negative, it will be decreasing. This method you have to follow to solve increasing and decreasing functions. Clear, students? So now let us go for the problems. Okay, students. So now let us see the first problem on increasing and decreasing functions. Clear? Okay. The function x to the power of 4 minus 4x is decreasing. They only have said that it is decreasing. So for that reason, there is no need to check it is decreasing or not. Directly, we should find the interval of decreasing. Please remember it. The function is decreasing in the interval. Clear? Suppose if the question was, check the function is decreasing or not and find the interval. In that case, you have to check first it is decreasing or not. Clear? Then you have to calculate the intervals. Clear? But here directly they are asking the intervals, so one step will be reduced for us. So for that reason, let us directly find the intervals. Clear? Okay. So f of x is equal to x to the power of 4 minus 4x. Clear? This is the given function. If I differentiate it, f dash of x will be equal to 4x cube minus 4. 4x cube minus 4 is f dash of x. So f dash of x is directly decreasing, means it will be lesser than 0. It will be lesser than 0. If the function directly they have given it is decreasing, that means it is lesser than 0. Clear? So now let us find the intervals, that is 4x cube minus 1. Let us take it is equal to 0. Our equation is equal to 0. Next, x cube minus 1 will be equal to 0. Clear? That is x cube equal to 1. It means that x is equal to 1. It means x is equal to 1. So you got only one root, that is x equal to 1. So now I can draw the waving graph. See here, this is positive function. It is lesser than 0, no problem, but the given function is positive. So for that reason, if I take this curve and if I see this, here it is negative, here it is positive. Clear? So given function is positive, here it is negative, here it is positive. So now minus infinity to 1, it is decreasing. Clear? 1 to positive infinity, it is increasing. Okay? So from this you can tell that this particular function is decreasing here in the interval positive infinity to 1. This function is increasing in the interval 1 to positive infinity. So therefore your answer will be, so this is not positive infinity, this is negative infinity. Here it is positive infinity. So negative infinity to 1, it is decreasing. Negative infinity to 1, it is decreasing. The given function is positive. Please remember, the given function is positive, so we draw from positive side. Clear? Don't get confused with this. Okay. So the function is decreasing in the interval minus infinity comma 1. I think the method is clear for solving the interval of decreasing function. Let us solve another one problem, so it will be more clear. Okay students. So now let us see the second problem on increasing and decreasing functions. For which interval the given function f of x equal to minus 2x cube minus 9x square minus 12x plus 1 is decreasing, they are asking. No problem. First you can see that the function is negative. Now let us see by differentiating what it will be, your f of x. So f dash of x will become minus 6x square minus 18x minus 12. So it will be the f dash of x. See here, f dash of x is also negative. As they have said it is decreasing, no problem, f dash of x is lesser than 0. Clear? For solving the intervals, what I will do, I will equate this term with negative sign on both sides. If I equate the negative sign on both sides, it will become 6x square plus 18x plus 12 equal to 0. I am equating with negative sign on both LHS and RHS. Negative sign will invert it to greater than, so that all things I am not going to discuss. just directly I will find the intervals by taking it equal to 0. Take 6 as common. X square plus 3x plus 2 equal to 0. This will be the algebraic equation. If I simplify, x plus 2 into x plus 1 will be equal to 0. So this will be the factorization of x square plus 3x plus 2 equal to 0. You are going to have x equal to minus 2 and x equal to minus 1. X equal to minus 2 and x equal to minus 1 as the two roots. So now let us draw it on number line with wavy graph method or wavy curve method. See, the function is negative, so that's why we should start with negative side. We should come back like this. Clear? So here it is negative, positive, it is negative. That means it is negative in two intervals. It is negative in two intervals. So for that reason, we have two elements. Sorry, this will be minus 2 in the increasing order you have arranged. If you arrange in the increasing order, it will be minus 2 and minus 1. So from this you can see that you have two intervals. Clear? I have to arrange in ascending order, that's why minus 2, minus 1, so on, it will be there. So here and here it is negative, there it will be decreasing. So they are minus infinity to minus 2 and minus 1 to positive infinity will be your answer. So that is minus infinity comma minus 2 and minus 1 comma infinity will be the answer for decreasing function. And then you can see that where it is increasing from minus 2 to minus 1. So in this it is increasing, here it is decreasing. Clear? Because here the function is positive and in this interval the function is negative. So for that's why in this fourth option will be the correct for the decreasing interval. If they ask the increasing, it will be minus 2 comma minus 1. I think the problem is clear. Please remember, here it is increasing, in the fourth option it is decreasing. Okay, so this is how you have to solve your increasing and decreasing functions. Okay, now let us go for the third problem. Clear? The function f of x cube minus 3x square minus 24x plus 5 is an increasing function in the interval they are asking. That means this function is increasing in which interval they are asking. So for that, let us find where the function is increasing. Clear? Okay. First let us calculate f dash of x. So if I calculate f dash of x equal to, it will be 3x square minus 6x minus 24. 3x square minus 6x minus 24. From this we have to calculate the intervals. For that you equate it to 0. It will be 3x square minus 6x minus 24 equal to 0. Clear? It is increasing means definitely it will be greater than 0. Don't worry about that. You equate it to 0, simplify the algebraic equation and let us find the intervals. Take 3 as common. X square minus 2x minus 8 equal to 0. So this is how you are going to get your algebraic equation. If I resolve it, you are going to have x minus 4 into x plus 2 equal to 0. You are going to have x minus 4. That means x comma minus 4. X minus 4 into x plus 2 equal to 0. Clear? So from this you can write x equal to 4 and x equal to minus 2. x equal to 4 and x equal to minus 2 you are going to write. From this you can calculate where it is increasing. Clear? So how to calculate? Draw the wavy curve method. This is minus 2, this is plus 4. Function is already positive, no problem. So if I draw the curve, it will be like this. Okay. Positive, negative, positive. That means 4 to infinity and minus infinity to minus 2. It is increasing. See here, minus infinity to minus 2, 4 to positive infinity, it is increasing in two intervals. So that's why 4 comma infinity union minus infinity comma minus 2 will be the correct answer. Clear? So option A is correct for your third problem. So from these three problems, I think now you got a clear idea of solving increasing and decreasing function. What you have to do? You have to take the given function, you have to see where they are asking for increasing or decreasing. So you differentiate it, equate to 0, solve the equation, you will get the roots, draw the wavy curve method. Then where it is negative, there it is decreasing, where it is positive, there it is increasing. Clear? So in this way you have to solve increasing and decreasing problems. Okay students, so now let us see one of the fourth problem on increasing and decreasing functions. Clear? Okay. Here, which one of the following statement is correct for f of x equal to sin 2x? They are asking which one of the following statement is correct for f of x equal to sin 2x. That means f of x is increasing in 0 comma pi by 2 and decreasing in pi by 2 comma pi. F of x is decreasing in 0 comma pi by 2 and increasing in pi by 2 comma pi. F of x is increasing in 0 comma pi by 4 and decreasing in pi by 4 comma pi by 2. And option D is all are correct. Okay. So here for this function you have to find the intervals where it is increasing and decreasing, then you have to answer. Are you clear? So for this function you have to check where it is increasing and decreasing, then you will have the intervals, so that will be the correct answer. Clear? Okay. So first let us calculate f dash of x. If I calculate f dash of x, what you are going to have? You are going to have 2 cos 2x. If I differentiate this term, you are going to have 2 cos 2x. Okay. So here 2x will be very important while solving, because if you take 2x as your theta for cos, what it will happen? See, little bit changes are going to show in outputs of cos angle. Clear? That is, here all the terms are in between 0 to pi by 2. 0 to pi by 2. So if I put 0 here, it will be 2 times of cos 0 will be 0. Clear? Next, if I put pi by 6, that is 30 degree, what you will get? 2 into cos of 2 times of pi by 6, that will be 2 times of cos 60 degree. If I simplify it, it will be 60 degree. 2 into 1, 2 into 3 cancel. So pi by 3 it will be 2 times of cos 60 degree. No problem. This is in first quadrant. This is in first quadrant. That means it is positive. Next, 2 times of cos. Here you have 30 degree. I will go for 2 times of pi by 4. That is 45 degree. Pi by 4 means 45 degree. So now 2 into 1, 2 into 2. Clear? So it will be 2 times of cos pi by 2, that is 0. Now you got, see, 2 times of cos 0 is 1, it was equal to 2, no problem. Cos 0 is 1, 2 times of cos 0 is 2, clear? It was 2 times of cos 60 degree positive, 2 times of cos pi by 2, it is 0. Are you getting my point? So that is, for this it is in first quadrant, for this also it is in first quadrant, for this also it is at first quadrant. Clear? So now if I take 60 degree, that means 2 times of cos 2 pi by 3. So where it will be? See, cos 2 pi by 3 it will be. That means pi minus pi by 3. It will be giving you pi minus pi by 3. That means it is second quadrant. Clear? So cos 2 pi by 3 will be in second quadrant. That means here it is negative, here it is positive. So what you are going to have here, from 0 to pi by 4 it was positive, from pi by 4 to pi by 2 it will be negative. Are you getting my point? See, first we calculated 0, pi by 6 30 degree, here pi by 4 45 degree. We are going on calculating 0, 30, 45, 60, 90. From 0 to 45 it was in first quadrant. As you cross your 45 degree towards 60 degree, it goes to the second quadrant. In the second quadrant cos is negative. If cos is negative, it will be decreasing. Here if cos is positive, it will be increasing. That means 0 to pi by 4. See here, 0 to pi by 4 it was positive. From pi by 4 to pi by 2 it is decreasing. Here it is increasing. Clear? So that means 0 to pi by 4 it is increasing, correct. Pi by 4 to pi by 2 it is decreasing, that is also correct. So what will be your answer? That is your option C. So here you can't go for your wavy curve methods because this is trigonometric formula. Wavy curve method is for polynomials and here it is trigonometrical function. So for that's why we will not go for wavy curve method. We have to solve it analytically. If your analytical skills are very good and very fast, directly you can say from 0 to pi by 4, because keep in mind, when you multiply your cos with 2, when you are going to multiply any trigonometric function with 2, your angles will be converging like this. If this is sine and this is cos, if I multiply this with 2 times, for this is sin x, clear? 0 to pi. This is pi by 2. Clear? If I multiply it with 2, they will converge together and pi by 2 will be equal to pi by 4 for sin 2x. Clear? That means this curve will become like this. It will converge itself. It will be converging itself as you multiply by 2. So that's why, see, here it is changing from 0 to pi by 4, pi by 4 to pi by 2, again it is changing. Clear? First it was from 0 to pi by 2, pi by 2 to pi. But when you multiply it with 2, it will converge half of this. Pi by 2, half of that means will be pi by 4. So it will, if you multiply by 2, your curve will converge itself with 2 times. That means pi by 2 will be converted to pi by 4. Pi by 2 will be converted to pi by 4. If you are getting sin pi by 2 as 1, you will get sin 2 times of pi by 4 as 1. Please remember that. You will get sin 2 times of pi by 4 as 1. by multiplying 2 to any trigonometric function, the graph or the values will converge or will converge in its range. The graph will converge itself. Are you clear? So this is how you have to solve. So now let us don't discuss it in detail, but you please remember, if your analytical thinking is very good, this type of problems will be very simple. Otherwise, you have to check each and everything. Here I have checked each and every element just to explain you. Clear? Otherwise, 2 times of cos x, it will converge, pi by 2 will be converted to pi by 4. Directly we should answer. No problem. Clear? But in detail we have to discuss that. I think this particular problem is clear to you. Next, I will go for the next type of problems. Okay, students. So now let us see maxima and minima of the given function. That is maximum and minimum of the given function. That means they will give you one function. Now, as you all discussed, the function is increasing in one interval and it is decreasing in other interval. In such a way, the function is going to have a maximum value for one term, that is x equal to a. That term you have to find, and what is maximum, that also you must know. Are you getting my point? That means the given function can reach maximum of how much values and at what value. That is very important. That gives you maximum. And minima tells that the given function can attain that much of minimum value for the given term, that x equal to a. Clear? So that topic I am going to discuss now in maximum and minimum of a given function, or maxima, minima for a given function. Clear? So for that, let us consider f of x is a function in the interval a comma b. In the interval a comma b, or f of x can be defined in any interval. You can take a and b are arbitrary points. Clear? Okay. So now f of x is said to have a maximum value of that term, that is a minus delta and a plus delta. A minus delta and a plus delta. This interval I will remove so that you will not get confused. Clear? So what I will do, I will take one point A for which I have to calculate maximum. That means if x equal to a, at this point, is it going to attain maximum or minimum, that I want to check. So then how to check? For this value of x equal to a, you should create a neighborhood a minus delta, a plus delta, where delta is approximately equal to 0 term. Clear? This is approximately 0, I am telling, no problem. But that approximately 0 means I think you are understanding what is the meaning of approximately 0. Clear? Now I will create a neighborhood a minus delta, a plus delta for this f of x. So what you have to check, in this open interval, f of x, that means x belongs to this interval. For every x belongs to this interval, that is neighborhood interval, x belongs to neighborhood interval, f of x must be greater than f of a. Are you getting my point? Sorry, f of a must be greater than f of x. F of a must be greater than f of x. That is, for every x belongs to this neighborhood, f of a must be greater. F of a must be greater than for every x belonging to this interval, so that this f of a is going to have a maximum value for the given function f of x. For the given function f of x. Again I am telling, for the given function f of x, if you want to calculate the maximum term, what you have to do? You have to choose one point A, you have to create the neighborhood, delta neighborhood for this A. Clear? After creating the delta neighborhood for this A, what you have to do? You have to check for this A, and every value of x in this delta neighborhood, f of a must be greater than f of x. For example, if this is f of x, if this is what general f of x, I will take one example of f of x. This is x equal to a. At this point you have x equal to a. Diagrammatically you can see that this is the peak point of this particular function and every other values are lesser than f of a. See, this point is what now? F of a. This is f of a. Choosing at x equal to a, I will take f of a. This terms give you f of a at x equal to a. This is greater. See the diagram. This is greater than every element of x. Every element of x belonging to this delta neighborhood. So now this point f of a will be the maximum for this particular function. Are you getting my point? So that means if you want to find the maximum value, what you have to check? For that a, the given a, for that the given a, you have to create one delta neighborhood, that is a minus delta, a plus delta. The values of this delta neighborhood must be lesser than this f of a. That means f of x must be lesser than f of a. Then we say that that particular point f of a is maximum of that particular function. On the same way, I will take this as another function. This is f of a. So now f of a is lesser than all the f of x terms in the delta neighborhood of a. Here what happens? F of a will be lesser than f of x for all the values of x in the delta neighborhood of a. If this is lesser, then what we call? For this is lesser than every element in the interval, that means this must be the minimum. If this is greater than every element in the interval, that means that is maximum. Clear? So they are also called as extreme points. They are also called as extreme points. Maxima and minima are called as extreme points. That is maximum. One side it is minimum. For this you can see that it is minimum. For this you can see that it is maximum. That is what your maxima and minima of the given function. In small sentences, if you want to say, maximum of the function is the greatest value of the function in the delta neighborhood of a. That is domain term. Clear? Next, minimum is defined as the lowest value of the function in the delta neighborhood of a of the domain. Clear? From this you can understand what is maxima and what is minima. Now let us discuss the problems and the algorithm of a problem of this particular topic, so that it will be very easy to solve the problems in your exams. First let us discuss algorithm before going to the problem, so that while solving the problem it looks very simple. Clear? But please remember, maxima and minima means, maxima means the maximum value of the given function in the delta neighborhood of a. Minimum means the minimum value of the given function at the delta neighborhood of a. Clear? So now let us see the algorithm. Okay students, so now let us discuss the algorithm for finding maximum of a function, that is maxima, minimum of a function, that is minimum. Clear? So to find the maximum, what we have to do, and for finding the minimum, what we have to do, let us see that. Clear? Okay. Let us consider f of x is the given function. Let us consider the f of x is given function. For this given function, what we have to do? We have to calculate f dash of x. We have to calculate f dash of x. Step 1. Step 2. equate this to 0. First calculate f dash of x. Next equate this to 0. Second, find the roots of f dash of x equal to 0. F dash of x equal to 0, that is x equal to a1. Consider x equal to a1 is root. Consider x equal to a1 is root. After getting the root, what you have to do? You have to differentiate again this f dash of x. That means you have to calculate f double dash of x. You have to calculate f double dash of x. After calculating f double dash of x, what you have to do? See here. If f double dash of x is lesser than 0, if f double dash of x is lesser than 0, maximum exist. That is maxima exist. F double dash of x is lesser than 0, maxima exist. F double dash of x is greater than 0, minima exist. Minima exist. Clear? F double dash of x is lesser than 0, maximum exist. F double dash of x is greater than 0, minima exist. Suppose f double dash of x is equal to 0, f double dash of x is equal to 0, then calculate f triple dash of x. F triple dash of x. Are you getting my point? First you have to calculate f dash of x, equate it to 0. Find the roots. Calculate f double dash of x at x equal to a1. At x equal to a1, if f double dash of x is lesser than 0, that means f double dash of a1 is lesser than 0, maxima exist. F double dash of a1 greater than 0, minima exist. F double dash of a1 equal to 0, then you have to calculate f triple dash of x. Again, after getting f triple dash of x, you have to again follow the same thing. F triple dash of a1 maxima exist. F triple dash of a2 greater than 0, minima exist. F triple dash of a1 equal to 0, then you have to calculate f fourth derivative of the given function. So like this you have to go on calculating unless and until you get maximum and minimum. Clear? So this is how we have to calculate. First f dash of x equate to 0, find the roots. If f double dash of root is equal to 0, then go for f triple dash of x. If f triple dash of x is f triple dash of a1 is also 0, then you go for f fourth derivative. Clear? Suppose f double dash of x is not equal to 0, in this one of the thing you are going to get, according to that you have to answer. If it is positive, minimum exist. If it is negative, maximum exist. Please remember, you will confuse. If it is negative, maximum will exist. If it is positive, minimum will exist. Are you clear? So now let us start the solving of problems on this. Okay students, so now let us see one of the problem on finding maxima of the given function. Clear? The value of the function x minus 1 into x minus 2 whole square at its maximum is. That means for this particular function, where it is going to attain the maximum and what is maximum they are asking. Clear? Okay. First let us write the given function f of x minus 1 into x minus 2 whole square, x minus 1 into x minus 2 whole square. Let us simplify this because it is not direct. Let us simplify this. F of x equal to x minus 1 into x square plus 4 minus 4x. Again let us simplify it. It will be f of x equal to x into x square x cube plus 4x minus 4x square. Simplify this. Minus x square minus 4 and plus 4x. If I calculate this, x cube minus 5x square, 4x plus 4x, it will be 8x minus 4. Clear? So if I simplify this, you are going to get x cube minus 5x square plus 8x minus 4. So from this, now you can calculate maximum and minimum. Clear? So for that, as I said in the algorithm, you have to calculate f dash of x, then equate it to 0, find the roots. Clear? So f dash of x equal to 3x square minus 10x plus 8. So this is your f dash of x. So now you have to simplify the algebraic equation by equating it to 0. By equating it to 0, if I simplify this algebraic function, it will be 3x minus 4 into x minus 4 into x minus 2 equal to 0. Clear? So that is x equal to 4 by 3 and x equal to 2. X equal to 4 by 3 and x equal to 2. So now you got the roots. What is the next step? You have to calculate f double dash of x. Clear? So what is f double dash of x? 6x minus 10. 6x minus 10. Now use the roots for finding maximum and minimum. So that is f double dash of 4 by 3 equal to 6 into 4 by 3 minus 10. That is equal to minus 2 lesser than 0. See, 8 minus 10 minus 2 lesser than 0. So here maximum exists. At this value maximum exists, that is f double dash of, at f double dash of 4 by 3 maximum exists. So that is f of 4 by 3 you have to calculate. F of 4 by 3, that is equal to 4 by 3 minus 1 into 4 by 3 minus 2 whole square. So you simplify this. 4 minus 3, 1 by 3. 1 by 3 into this is 4 minus 6 minus 2 by 3. Make a square of this, and if you simplify, it will be 4 by 27. So option D will be your answer. See here, f double dash of x is lesser than 0. If f double dash of x is lesser than 0, maximum exists. So maximum is f of 4 by 3. So f of 4 by 3 equal to 4 by 3 minus 1 into 4 by 3 minus 2 whole square. If you simplify that, you are going to get 4 by 27. So that is your maximum at 4 by 3. Maximum value at 4 by 3. If you want to check for x equal to 2, also you can check. What will be f double dash of 2? F double dash of 2 will be 12 minus 10, that is 2. Greater than 0, so minima exist. Minima exist at x equal to 2. If you want to find minima, come again here and put here 2. So 2 minus 1 2 minus 2 whole square. So 1 will be what? 0. So 0 into anything is again 0. So if you calculate this, it will be 0. 0 will be the minimum and 4 by 27 will be the maxima for this particular question. See, 0 also present here. That is minimum. That is minimum. That you have to calculate whenever f dash of x is, f double dash of x is greater than 0. F double dash of x is greater than 0. You have to calculate that, and suppose if f double dash of x is lesser than 0, you have to calculate the maximum. Clear? So from this, I think you got an idea of calculating maximum and minimum. Okay students, so now let us go for the next problem. The maximum and minimum value of the function mod of sin 4x plus 3. See, the problem is asked on one trick. As we all said, to find the maxima and minima, the function has to be differentiated, but they have given the mod function. As you all know, mod function is not differentiable, so number of students will get confused for answering this question. Clear? That's why they have asked this. But no worries, let us find with another way. Here you have sin 4x, so sin 4x must be always lesser than, greater than minus 1 and lesser than plus 1. It can't go lesser than minus 1, it can't go above plus 1. It should be in between minus 1 and plus 1. That is what the range of sine function. Clear? Okay. So that means for this minimum is minus 1, for this maximum is plus 1. 3 is constant, so no worries. So that's why for maximum mod of 1 plus 3, for minimum minus 1 plus 3, here it is 4, here it is 2. How simple this problem is, but some students will get confused by seeing the mod function where it is not differentiable. Then how to solve this? They will get confused and they will not answer this question. But you know the sine function range. Using that range from minus 1 to plus 1, minimum is minus 1, maximum is plus 1. You have only one function here. This is constant, no problem. So 1 plus 3 is 4, maximum. 4 is maximum, 2 is minimum. So option B is correct answer for this. Clear? I think you have no confusions in this problem. Okay students, so now let us see the third problem of finding maxima and minima. Local maxima is nothing but maxima, local minima is again a minima. Values of the function x minus 1 into x plus 2 whole square. This f of x equal to x minus 1 into x plus 2 whole square. So directly let us differentiate. F dash of x equal to x minus 1 into x plus 2 multiplied with 2. First I will differentiate this. 2 into x plus 2, it will be plus. Another one is what? You have to differentiate x minus 1. So it will be x plus 2 whole square, and differentiation of x minus 1 is 1 itself. Clear? So differentiation of x plus 2 whole square, 2 into x plus 2, differentiation of x minus 1, it is 1. Okay. So you got f double dash of x. Now let us simplify this for 0. F double dash of x equal to 0, that is x minus 1, 2 into x plus 2 plus x plus 2 whole square equal to 0. What is common? X plus 2 is common. 2x minus 2. This term I will write here. plus x plus 2 equal to 0. One of the x plus 2 is present. Minus 2 plus 2 cancel. So remaining is x equal to minus 2. If I simplify this, you are going to have 2x plus x will be 3x. So x is equal to 0. Clear? 3x 0. 3x 0 means x is equal to 0. Therefore here you have x equal to minus 2. So minus 2 and 0 are the two roots of this particular equation. Clear? Okay. After getting the roots, you have to calculate f double dash of x. Clear? So you have to calculate f double dash of x and solve maximum and minimum. So for that, what I will do here, you have to calculate f dash of x. But what they are asking, local maximum and local minimum, both they are asking. So for that, no reason to find f double dash of x. If f double dash of x greater than 0, that is maximum. Sorry, f double dash of x lesser than 0, that is maximum. F double dash of x greater than 0, that is minimum. You have two values, which one is greater, that is maximum, which one is lesser, that is minimum. So in that, all details I will not go on writing, because we will solve it very quickly. If we all go on writing, it will take time, so I will not write all those things. I will directly find maximum by putting x equal to minus 2 and 0 in this f of x. So f of x, for that f of minus 2 equal to minus 2 minus 1 multiplied with minus 2 plus 2 whole square, it is 0. Clear? Another one is f of 0. So f of 0 will be equal to, put 0 here, minus 1, put 0 here, 2 square, that is minus 4. Clear? So you got two terms, that is minus 4 and 0. In these two, this is minimum and this is maximum. So that we can save the time. For just saving the time, I have not solved f double dash of x. Again, f double dash of x has to be checked with minus 2 and 0. Again, you have to solve for f of x. That all terms I have not calculated, just to go quickly to the answers, because it's a common sense that after differentiation equate to 0. You will get the roots. You have to check with that roots in f double dash of x. F double dash of x lesser than 0 maximum. F double dash of x 0 greater. F double dash of x is greater than 0 minimum. In that, one must be greater, another must be smaller. That is common sense. So which one is greater, that is maximum. Which one is smaller, that is minimum. For that, I will don't write in detail all those terms. In detail, I will not write. Just I will solve f dash of x equal to 0. After solving f dash of x equal to 0, I will get two terms. That two terms in your theoretical form, you have to check f double dash of x. Clear? But I will not write f double dash of x. Directly I will put those terms here. One of the term will be maximum and one of the term will be minimum, so that we can save the time. Clear? So minus 4 is minimum, 0 is maximum. See, maximum, minimum. So 0 is maximum, minus 4 is minimum. That's why option B is correct answer. Okay students, so now let us see the next problem. Local maximum value of log x by x. Okay, the first function is log x by x. As you all know, you have to calculate f dash of x, equate to 0, find the roots, go for the double differentiation, put the roots in double differentiation, check f double dash of that root is lesser than 0 or greater than 0. If lesser than 0, maximum value exists. If greater than 0, minimum value exists. That all term you have to solve step by step. But it will take a time. For that, I will skip all those f double dash of steps, because after solving f dash of x, definitely you will get the roots. In that roots, one must be the maximum, another must be the minimum. So we need a maximum, that maximum we are going to write. So for that, what I will do, I will calculate f dash of x, u by v form. If you simplify u by v form, it will be x into 1 by x minus log x divided by x square, u by v form. Quotient rule of differentiation. Clear? Answer x and x minus 1 log x divided by x square you are going to get. Clear? So after getting f dash of x, what you have to do? You have to equate it to 0. F dash of x equate to 0, that is 1 minus log x divided by x square. Equating this term to 0, if I simplify 1 minus log x equal to 0, what you are going to get? Log x equal to 1. Clear? So if log x equal to 1 implies x equal to e. Clear? Because if I take log on this side, it will be x equal to e to the power of 1. By simplifying this equation by exponential properties, it will be x equal to e to the power of 1. So that is x equal to e you are going to get. That means you have only one root. Clear? So that must be the local maximum. That's why they have asked only one maximum. They have not asked the minimum. Clear? So x equal to e gives you the local maximum value. Clear? So for that reason, what I will do here, I will take f of e, that will give you local maximum. So that is f of e equal to log e divided by e. So that is log e to the base e is 1 divided by e. Answer is 1 by e. So this 1 by e will be the correct answer for solving local maximum. Clear, students? From this you got the answer, that is 1 by e. Okay, students. Now let us go for the fifth problem, that is maximum value of 1 by x to the power of x. Clear? So here differentiation skill must be very good. If your differentiation skills are very much good, this will be solved very quickly. Otherwise, it takes time. So first I will explain your differentiation in detail. Those who are having the skills of differentiation very quickly, they can get answer very quickly. No problem of that. But let us discuss in detail. Clear? Okay. Here it is in the form of f of x to the power of z of x. Are you getting my point? So that is in the exponential form. So you have to apply log on both sides. Are you clear? So for that, what I will do, I will take f of x equal to 1 by x to the power of x. I will take it in this form. Clear? So it is in the form of f of x to the power of z of x. F of x to the power of z of x, exponential, both are functions. Here you have to apply log on both sides. If I apply log on both sides, what you are going to have? Apply log on both sides and differentiate. Apply log on both sides and differentiate. What you are going to get? You have to differentiate this function by applying log on both sides. You have to apply log on both sides and you have to differentiate. Clear? If I apply log on both sides and if I differentiate, you are going to have 1 by f of x into f dash of x equal to x I will write as it is. Log of 1 by x differentiation will be 1 divided by 1 by x into minus 1 by x square into minus 1 by x square plus now log of 1 by x you have to write as it is. Differentiation of x will be 1. So I am directly writing the differentiation. So now you are going to have minus 1 if I simplify this plus log of 1 by x. Therefore, the flash of x will be equal to 1 by x to the power of x into log of 1 by x minus 1. These terms you are going to have. If you have these terms for the f dash of x, now our regular method is find the roots, calculate f double dash of x, check where it is lesser than 0, check where it is greater than 0, then you have to answer. But we shall not follow those terms here. Directly I will equate this term to 0 and I will find the roots. Okay. So equate this term equal to 0. What you are going to have? 1 by x to the power of x is equal to 0, or log of 1 by x minus 1 is equal to 0. These terms you are going to have. See, this cannot be equal to 0. 1 by x to the power of x cannot be equal to 0. This term must be equal to 0. What you are going to have? You are going to have 1 by x log, this is 1 by x e to the power of 1. So x will be equal to 1 by e. X will be equal to 1 by e. If you simplify these terms, therefore your maximum term will be what? Put in, so x equal to 1 by e, put this in f of x term. So that is 1 by e whole to the power of e, because f of x is 1 by x whole to the power of x. If in the place of x I write 1 by e, it will be equal to 1 divided by 1 by e, that is e to the power of 1 by e. Clear? So e to the power of 1 by e will be the maximum term, that is option B. Here don't sit with solving f double dash of x. You will be having very lengthy problem if you calculate f double dash of x. So you skip all those steps. Just you got one root. For that one root, they are asking only the maximum. So that for that term only it will be the maximum. So that's why e to the power of 1 by e will be the maximum value of this particular question for the function 1 by x to the power of x. I think you got the answer. Clear? If you don't got the answer, again see here. It is in the form of f of x to the power of g of x. You have to apply log on both sides and you have to simplify. So for that reason, this is the given function. Apply log on both sides. 1 by f of x into f dash of x. If I differentiate by putting log on both sides on LHS, you will get x into 1 divided by 1 by x into minus 1 by x square plus log of 1 by x. If you differentiate on RHS, if you further simplify, you will have minus 1 plus log of 1 by x. This f of x will be multiplied to this term 1 by x to the power of x log of 1 by x minus 1 you are going to have. Here you have to equate this to 0. If you equate this to 0, x equal to 1 by e you are going to get. After getting x equal to 1 by e, you have to differentiate f double dash of x and check is it lesser than 0 or not. That particular step there is no need to solve here. Directly put 1 by e in your f of x, so that you are going to have that maximum term, because definitely it is going to be the lesser than 0. Then you know that it is going to get a maximum term. Don't solve all that time. If you are interested, you can double differentiate it, put x equal to 1 by e, it will be lesser than 0. Then you can come for putting x equal to 1 by e here. But what I say is, definitely you have only one root. Definitely it will be f double dash of x will be lesser than 0. So if f double dash of x is lesser than 0, then you have to put that 1 by e in f of x. Before solving all that, directly if you put 1 by e here, that is what your answer. Clear? So put 1 by e there. So B option will be the correct answer. Okay students. So now let us go for Rolle's theorem and Lagrangian mean value theorem. Clear? So first let us see Rolle's theorem. What Rolle's theorem tells? Let us see what Rolle's theorem tells. F of x must be continuous in closed interval a comma b. F of x must be continuous in closed interval a comma b. F dash of x must exist. F dash of x must exist in open interval a comma b. F dash of x must exist in the open interval a comma b. Then also f of a must be equal to f of b. F of a must be equal to f of b. That is f of a must be equal to f of b. Clear? Then there exists f dash of c equal to 0 such that c belongs to open interval a comma b. C belongs to open interval a comma b. That means f of x must exist and continuous in closed interval a b. F dash of x must exist in open interval a comma b. F of a equal to f of b. Then there exists f dash of c equal to 0 such that c is in your open interval a comma b. Clear? That means, or you can say that for this such that here you can put there exists c belongs to a comma b. That means then there exists c belongs to a comma b such that f dash of c equal to 0. Clear? That means there is a point c in your open interval a comma b. There is a point c in your open interval a comma b such that for that point f dash of c is equal to 0. For that point f dash of c equal to 0. That is what your Rolle's theorem. Clear? If in exam, if they give you one function and they ask to verify the Rolle's theorem, you have to check all these conditions. Is it continuous or not? Is it differentiable or not? F of a is equal to f of b or not? Then if these three conditions satisfy, there exists c belongs to open interval a comma b such that f dash of c is equal to 0. F dash of c is equal to 0. This is what, how to verify your Rolle's theorem. If all these conditions satisfy, then we say Rolle's theorem is verified at the point C. Rolle's theorem is verified at the point C. If you check all these terms and if you understand all these terms, solving the problems will be very easy. First I am saying it must be continuous, it must be differentiable, f of a must be equal to f of b, then there exists a c belongs to a comma b such that f dash of c is equal to 0. That is very, very important. Clear? Now let us solve problems on this, friends. So let us see the problem on Rolle's theorem. For which interval the function defined satisfies all the condition of Rolle's theorem. That means for this particular function, in which interval of this following Rolle's theorem is verified, they are asking. Clear? Okay. Let us see 0 comma 3. What will say 0 comma 3? This is f of x square minus 3x divided by x minus 1. Here you can see that this is polynomial, this is polynomial, f of x is a polynomial, g of x is a polynomial. Polynomial function is always differentiable. Here this is also differentiable, no problem. As well as they are continuous, that is also no problem. They are not continuous at 1, but that 1 is not present here. Oh, okay. See here, 0 to 3. in 0 to 3, 1 belongs to 0 to 3. Are you getting my point? For 1 belongs to 0 comma 3, this function is not going to be continuous. This function is not going to be continuous because f of 1 is equal to not defined. F of 1 is equal to not defined for this function. Therefore, definitely it is not going to be a continuous. LHL and RHL are not going to be equal to f of 1. Hence, this particular function in this interval does not satisfies Rolle's theorem. First one is deleted. Clear? Come to this. Here 1 is not present, so that's why it is continuous as well as differentiable. No problem. It is both continuous and differentiable in this interval because 1 is not present here. Therefore, let us check f of minus 3. What is f of minus 3 here? This is 9 plus 9 minus 3 minus 1. That is 18 by minus 4. 18 by minus 4. What is 0? If I write 0 here, this term will be 0, 0. 0 by anything is 0. F of 0 is equal to 0. Therefore, f of minus 3 is not equal to f of 0. Again, Rolle's theorem is not verified here also. Are you getting my point? So, again the same, you put 3 here. 3 square is 9. 9 minus 9 it will be 0. F of 3 will be equal to 0 for this function. 3 square 9, 9, 3 into 3, 9, 9, 0 by anything is 0. Therefore, f of 3 is 0 where this is not equal to f of 1.5. For this, f of 1.5 will be not equal to 0 if you put 1.5 in this x. Hence, f of 3 is not equal to f of 1.5. This is also not your interval where Rolle's theorem is verified. Hence, none of these is your answer. Clear, students? This is how you have to simplify this particular problem in which following intervals Rolle's theorem is verified. I think you got the solution of this particular question. Okay students. Now let us see Lagrange's mean value theorem. For this also there are 3 conditions, that is f of x must be continuous in closed interval a comma b. First condition same for Rolle's theorem. F of x must be differentiable. F of x must be differentiable in open interval a comma b. Second is also are satisfied. If these 2 conditions are satisfied, then there exists C belongs to open interval a comma b such that f dash of C is equal to f of b minus f of a divided by b minus a. In Rolle's theorem, this is same. The third condition in Rolle's theorem is f of a equal to f of b. That thing here we are not going to verify. Directly we will go for there exists C belongs to open interval a comma b such that f dash of C equal to f of b minus f of a divided by b minus a. Clear? Because if these 2 terms are equal, here it is going to be 0. 0 by anything is again 0. Clear? So in that case answer will be trivial. So here the condition, that is third one, f of a is equal to f of b is not included in your Lagrangian mean value theorem. Lagrangian mean value theorem tells that it has only 2 conditions. It should be continuous, it should be differentiable, then there exists C belongs to open interval a comma b such that f dash of C is equal to f of b minus f of a divided by b minus a. Are you clear? So if you solve this, you are ready to tell that Lagrangian mean value theorem is verified. Lagrangian mean value theorem is verified. So keep in mind, the third condition is not included in Lagrangian mean value theorem. Okay students, let us see the problem on Lagrangian mean value theorem. What Lagrangian mean value theorem tells? F of x is continuous, f of x is differentiable, then there exists C belongs to open interval a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. Clear? So using all these conditions, we have to solve the problems on Lagrangian mean value theorem. So in this problem, what they are asking, for the function f of x equal to e raised to x, a equal to 0, b equal to 1, the value of c in mean value theorem, the value of c in mean value theorem they are asking. Okay, this is what the formula for finding value of c. Already they have said we have to find c in mean value theorem, means mean value theorem is already satisfied. Anyways, e power x is differentiable, e power x is continuous, hence Lagrangian mean value theorem has to be applied. Therefore, let us find by using this formula what will be the c value. They have given a, they have given b, no problem. Okay, so f dash of c is nothing but what? Differentiation of f of x is again e raised to x, it will be e raised to c. So e raised to c will be equal to f of b. B value is 1. F of b is e to the power of b minus f of a is 0, e to the power of 0 is 1 divided by what? B minus a. B is 1, this is 0, 1 minus 0 is 1. So here what you are having, e to the power of c is equal to e to the power of b minus 1. E to the power of b minus 1 you are going to get. F of a is e to the power of a is 0, so that is 1, no problem. So e to the power of c equal to e to the power of b minus 1. Clear? So then this is going to be as, see here, b value is what? 1. B value as 1. If you put b value as 1, it will be e minus 1. E to the power of c is equal to e minus 1. Clear? So e to the power of c is equal to e minus 1. So what are your options? Log x, log of e minus 1, 0, 1. Clear? Okay. If I take e on this side, it will be c equal to log of e minus 1. Clear? By the properties of log and exponential functions, if I take e on this side, it will be log of e minus 1. Clear? So hence your answer will be log of e minus 1. Clear? So this is how you have to solve. These are the two conditions for Lagrangian theorem. Hence f dash of c equal to f of b minus f of a divided by b minus a. Using all this, I take f dash of c formula. F dash of c equal to what? F dash of c is equal to e to the power of c. E to the power of c equal to f of b minus f of a. Here f of a means e to the power of a is 0, e to the power of 0 is 1. E to the power of b value is 1, e to the power of 1 is e. Clear? So e to the power of c is equal to e minus 1. If I simplify that, c is going to be equal to log of e minus 1. Hence option B is the correct answer. Okay students, so till now we have solved the concepts of application of differentiation and the problems on the concepts of application of differentiation. So almost all the concepts I have covered in this particular topic. I recommend you to all that to solve more number of problems other than which I have solved from other books. You take and you solve more and more number of problems so that the concepts will be clear. Okay.